So I want to just say once again, you're all welcome. I want to do the estimation of the MAMCO's productivity index in R. Okay. But before we start, I want to remind you of the data set. So I'm showing you the data set. If you can see the data set, let me know. This is the data set which I have highlighted right here. Okay. Do you see the data set?
Yes.
Yes, Doc.
Okay. So you can see that the data set is still what we've been using all this while. Okay. If I take you to the notes, and again, it's good to do that. Take you to the notes so that you have a feel. If I take you to the notes, you will see that this is the data set. If you see the data set here, let me know. Do you see it in the notes?
Yes.
Okay.
Yes, Doc.
So this is a data set that we've been using. And if you have your own, which is an output orientation, you can use that alone. This data set is made up of 2 inputs and 1 output. The output has been normalized to 1 so that we can draw it in an input space, okay, or input requirement set. We've been able to plot this data. We've been able to calculate it. We've been using it. Let me just remind you about the graph of this. Okay, this is how it looks like. Okay, this is how it looks like. I don't know whether you can see it, but this is how it looks like. And we've been using this data set throughout the video. The firms are in year 0, the blue frontier, and then the same firms are in year 1, the red frontier. And the data set has been shown some few minutes ago. So this is a data set. What I'm going to do is I'm going to estimate the MAMCO's productivity index. Is the process. It is a process of estimating it that is more important. Okay. So I'm going to go to the data. I'm taking these data sets into Excel, from Excel to R. Okay. And I'm sure by now you all know how you take a data set. You can use a clipboard and just copy the whole data set like I'm doing now. Okay. And watch the way I've labeled the data set. Okay. Remember. So year 1 is there, year 2 is there. I think I need a time. I need a time, but even if you don't have the time, no problem. So let me just copy the data set. The same firm A, as you can see up there, same A is showing itself again, because the second one is the second year. You copy this data set, you go to R, let's go to R, and then you install the data set. You drop the data set in there. Now, in command number 87, let me just show you something. In command number 87, you see that I've already written my command, and I'm just calling the data set P in R. So you can see that I have P, read.delm, okay. And I've loaded the data set. How do I know? Look down there in the console. I've loaded the data set. So that will import both years' data into the Excel. Now that I'm in the data set, you want to be able to Command R to recognize some of the information in the data set. Command R to do that. So I am using X0, capital X0, and I'm calling this X0 to be the column binding of all the inputs. Now, how do I know it's all on it? The inputs are X1. So all the inputs X1 and X2, which is in year 0. So that is the first year. I'm putting it into a matrix, okay? So when you write the C bind with a bracket, P is the name of the data. So you read it backward. You say that X1, which is inside the data set called P, the dollar is what gives you the command, okay? And that data set from row 1 to row 5. So that is from firm 1 to firm 5, okay? The same thing for X2, the input X2, which is in the data set P, from firm 1 to DMU5. They should be column binded, okay? and then create a matrix of that and call it X0. So once you run this command, okay, you will have the data set. For you to know what you've done, just highlight only the X0. Please, I hope you see my screen, right? Highlight the X0, and then you enter, and you will tell you the information. So even though the whole data is together, this part of the data, the first 5 frames, with the input X1 and X2, that's what you're seeing here. You do the same thing for the Y0. See, the Y0 are the frames in year 0, they are outputs. You're putting them into a matrix. And so you use the same cbind, okay? And for this output, we don't have Y1 and Y2, we have only Y. So Y, which is inside the data set P from frames 1 to 5, they are the ones you're interested in. You generate a matrix for that. If you want to see how it is, just highlight only the Y0 and then Control Enter. And that will tell you that these are the information. Now, I'm going to create, okay, an index for all of them, the firms. Okay, R requires that you create an index for the firms in year 1. So whenever you are doing this R, you do it year by year. So if you have year 1 and year 2, you do it year by year. Okay, but of course, there's something that you can use that will do for everything for you when you're doing it for all. So you create an index, and the index again is for the first year. So you run it. Okay, so the index is referring to the firms that will form period 0 frontier. Okay, that's the first year frontier. And in your case, we have A, B, C. So when you actually go and then highlight to see what the IDO means, it is telling you the A, B, C, the firms that are making up the frontier. Okay, and then there could be numbers. It could have been numbers instead of A, B, C. It could have been Akosia, Anna, John. It could have been the actual names of the firms. It could have been the name DMU1, DMU2, DMU3. Okay, it could be anything. And then you do the same thing for the year 1, because that was for the year 0. And remember, for the year 1, it is for the firms from row 6 to row 10. So for the input X1 and X2, you have to change the rows numbers from row 6 to row 10. So if you have other years, year that, it will continue in that form. You create a matrix for X1, create a matrix for Y1, create an index for ID1. Okay, so I've done all of that quickly. Now, we are going to use 2 things. See, there are 2 packages that you can use in R to be able to do this. One is very effective in this context, okay, because it gives you more of the decompositions. The other is not that much effective. Well, it's also effective, but it does not give you all of the decomposition. But we'll do both of them so that you know, because each one has its advantage. The first one is the benchmarking. The benchmarking is the one by Otto and Bogotov. It said that benchmarking package, you have to install it. In fact, by now you've installed it because you've used it for the efficiencies. You have to install it. That benchmarking package is the one that is a little bit limited. Okay. But still, let me show you. And one of the things is that you can draw the graphs. Okay. You can draw the graphs, the MPI graph. You can draw the graph actually for the input-output, like the one I hand drew. But to draw it for the input for the ManQuest is quite difficult. Okay. But I am using input. You guys are using output. Okay. And so because I'm using input and you guys are using output, it means that you can't draw the graph effectively. Oh. The system cannot find a file. Let me just. All right. So you have to invoke the benchmarking. Oh no. So how did you invoke it? They just do live for some reason. Okay, so I've invoked the benchmarking. So once you've invoked the benchmarking in command number 94, as you see here, then you now estimate the ManQuest. Okay. So I'm about to estimate the MAMQuest, and let me just take you back to the slides so that you appreciate something. So I'm about to estimate this MAMQuest, and that is MPI. I gave it a name called MPI. Remember, I could have simply called it J. Doesn't matter. Okay, write a MAMQuest equal to MAMKill. You bring all of your year one information for the input, output, and then the indexes. You bring all your year two information, which in this case, X1, X1, ID1. And then you bring your returns to scale, whether you are doing VRS or CRS. As you can see, the returns to scale is VRS. The orientation is input, because my graph I'm dealing with now is an input-oriented graph. Okay. If you want to change the orientation, it's simple. You can change it. Okay. If it is CRS, you can type it there. NDIRS, you can type. NIRS, you can do it. Okay. And you run the command. Okay. So that is what we're about to do. We're going to run the command. I'm going to do that in R. So once you run this command, pow, the results is there. But in order for you to see the results, so first there are two things you can use to get a result. You can go and then get a result straight away by highlighting just the MPI I wrote, just the MPI, and running it. It will give you the details of the result. But I normally like to put it in a beautiful command and rename it in a printout, like an Excel will accept it. I'll come to that. But first, let's see the results, MPI. So you highlight only the MPI in command number 96, and then you run, enter. You will see the beautiful results down there. Let me go to the beginning, then you can appreciate it. So what are the results? Look at it. The first result is M, they call it $M. And again, when you look at the help section, it will tell you what each of them is. This $M is the actual MAMQuest result. That is a MAMQuest. Now, the beautiful thing about the benchmarking is that it will give you the results in the way that they should have been interpreted. It will give you, because benchmarking is using efficiency scores. FEAR, which is the other package you shall deal with, it uses distance functions. And so because benchmarking is using efficiency scores, the good thing is that you will get the results where you don't have to take the reciprocals again. In this case, the MAMQuest score productivity for each of the firms was 1.428. So 1.43, 1.43 for each one of them, except what? DMUE. So you can see that DMUE is getting a score of 2.142. Guys, could you confirm that when we did the mathematical computation by manual, is that not the score we had? That was the score we had, right? That was the score we had, right? Okay.
Yes, Doc.
All right, so that was the score we had. So you have this score, and that score is 2.14. And we said that it means that firm E has increased its productivity by 114%. Okay. Now you guys will notice why that is so true. Let me take you back to the, and again, when you compare this with a graph, it helps you to be able to appreciate the whole thing better. Okay. So when you look at a graph that I'm looking at here, you will see that DMUE was inside the blue frontier. It was inefficient. Okay, but when we came to the next year, the year one, from year 0 to 1, the DMUE, which was inside the frontier, in the year 2, it is on the red frontier, just as where B is, B1 is. So you can see that it was inefficient in the previous year, but in the current year, it is what? Efficient. So it has already, first of all, improved its performance already. Now remember, DMUA was on the frontier, the blue frontier in year 0. But when we came to year 1, which was the next year, it's also on the frontier. So it is on the frontier before, it's on the frontier now. It's not changed. It's not changed. And that is why, Okay, but of course, something has changed. Something has changed, and we'll come back to that. And we'll look at the details of that when we're looking at the results. So let's go back to the results. So in the results, you can see that each one of them have also improved their productivity, okay, by about 43%, 43%. But DME has improved its productivity, has experienced progress more because it was originally inefficient. The decompositions, the software benchmarking gives you only the technical change, which is the TC, and then the efficiency change. And when you look at efficiency change, you can see that DME has improved its efficiency. And that is what we had in the manual computation, 1.5. All the others have not improved the efficiency. I just showed you some few minutes ago. Why haven't they improved? Because they were efficient before, they are efficient now. So in terms of efficiency change, they have not. But the technological change is also shown up here. You can see that the technological change for each one of them was 1.42. In fact, it was the same all through. So what this means is that it appears that technological change works Higgs neutral. It appears is Higgs neutral. What does that mean? It means that it was parallel. The graph of the line was parallel. Okay, that is what it shows there. So what is driving productivity for these firms? What do you think is driving productivity? For firm A, B, C, D, you can see that what is driving productivity is not the efficiency stagnation. It is rather the technological progress. The technological progress. That's what is driving productivity progress. All right. So you are able to get a score. The only thing is that you get only the two-part decomposition. Of course, the on period and cross period efficiencies are also shown. So when you come down, you will see the on period efficiency E00. It is shown there. On period efficiency for each of the firms is shown. Cross period efficiency for each of the firms is shown. On period for the second year is shown. And when you scroll down, the cross period for the second year is also shown there. So that is it. Now, one of the things you can do in command number 97 is to print the results nicely. So I use VOO to represent the on period efficiency. And then I take the information from inside the result and then rename them. This is a VRS. That's why I'm using V. If it was a CRS, I will use C. And then look at the latter part. The latter part, say let EC imply the efficiency change, which is inside the results MPI. And let TC do that, and let the MAMCO store do that. Correct them to 3 decimal places. So this command will print the entire results nicely. Let me show you how it looks like. Now you can see down there, the entire results are nicely printed out. So you can export this to Excel, and then you can now see them nicely arranged in Excel. So you can see the efficiency change column, technical change column, MPI for all of these between the 2 time periods. Okay. So that is how you estimate the MAMQuest productivity index. But again, if you remember the decomposition of Ray and Desli, the decomposition of Wheelock and Wilson, Zofia and all of that, they are not here. So the benchmarking is a little bit limited. It does not give you the real information that you need. So we have to tend to what? Fear. We have to tend to fear. So, ladies and gentlemen, at this stage, I'm going to go to fear and show you how you do it. In order to be able to use the fear package to do your, because the fear has some couple of advantages. In order to do the fear package, you have to install it from Professor Paul Wilson's website. And I have a video that directly shows you how you can do that. So please watch the video. This is a website. You download and use it. Now, when you download, you will get the zip version there. And you can now go to your R and pull it on your computer, the zip file, and then use it. So let me just give you a brief idea of what I mean, okay? Because this part could be a little bit green for some people. So let's say that I want to invoke FEAR, okay? What you need to do now is to go to packages. Okay? On the far right of your R, go to packages. And then in the list, okay, I have installed FEAR, but if you have not installed FEAR, you go to install, and then you will not take it from the repository of CRAN. You will now click and select package archive zip. At this stage, it is already inside your computer somewhere. That folder, you direct it to that folder. And then, so normally when you click zip, okay, it will open the folder. It will open it. And then you have to search your computer and identify which folder the thing is, the zip file is, the FEAR zip file is, and then you just open it, and then you come and then you just install. But I have already installed it. So I'll do a cancel of this. And then look for the FEAR. So when you search in the example, you see FEAR, frontier efficiency analysis with R. Okay, you can invoke it. You can click here to invoke it, or you can use command number 101 here to invoke it. Okay. Let me click to invoke it. All right. So there are some few things that are maxed because I'm using FEAR and benchmarking here at the same time. So some of them will be maxed. In other words, it will be hidden, but still, let's go ahead and do it. So once you do this, let's load the data. You see, the way FEAR is going to see the data is slightly different from the way benchmarking saw the data. So to load the data, you go to your Excel again. Okay. Go to your Excel again, and then you copy the data set again, and you come to your R. And then you use the command. I'm not using the same P. This time I'm using MF. Okay, so let me load the data this time. Now let me show you the data, how it looks like. Okay, it looks down there like this. All right. At this stage, if you want to know the names of the data set, just run the command names of the data. And the headings are DMU X1, X2, Y. So you have the names of the data. Now, I'm not going to use a column bind. I'm going to use a matrix R bind, a row bind. So I'm going to do a row bind of the whole thing. It's just distance functions. R here is using distance functions. So I just have to put them in a matrix row bind way to be able to get them well. So similar to the other one, you can create X1, X2, okay, Y1, Y2, just like the previous one we're doing. I could have called it 0 though, X0, X1. So just know that year one is the X1, year 2 is the X2, or year 0 is the X1, year 2 is the blah, blah, blah. So you put them into matrix, which is 1 to F, in this time, the data set, which is M. And here you have to indicate the row, the number of rows. And because you are dealing with the 2 inputs, the number of rows are 2, X1 and X2. Okay. When we come to the output, you see that the number of rows are 1 because there's only 1 output that we are dealing with. You run all of these matrices. And then there are indexes. Remember, we've gone through all this already. Now, at this stage, something is important. And what is important here is importantly important, okay? Because there are some few things to note. Now, the data set I'm using is a balance. So note that you will not always have to have balanced data. Sometimes you deal with unbalanced data. So take note of that. You can deal with unbalanced data. If you look at the next command, and I'm going to show you that here in the note. The next command we are going to use to estimate the MAMQuest is MM. I'm just calling it MM. You could have called it K. But the actual command is MAMQuest.component. So this is going to give you the MAMQuest plus the component. And you have to just indicate all the matrices, X1, Y1, ID1, X2, Y2, ID2. The orientation here is 1. 1 is for input orientation. 2 is for output orientation. 3 is a hyperbolic graph orientation. Okay, so these are all in the help section. The next thing is the number of replications. Now, this is when you want to do bootstrapping. Okay, bootstrapping. Okay, and the number of replication for the bootstrapping is suggested always to be 2,000. I will teach you bootstrapping separately. Why we got to do bootstrapping, the importance of it, when to do it, because it's not a magic. Okay, and in this case, the number of replications for the bootstrap samples is 0 because we don't want to do bootstrapping yet. And then you can command R to check the errors. So this is going to define only the components of the MAM quiz. Okay. And the good thing about this is that you don't need to specify the orientation. The results is going to give you both constant returns and variable returns scores. You're going to get all of them at the same time. Okay, so let's go and then run and then do this. You will do this on your own, so you got to know how to do it. Now, if you look at the orientation, I have written 500 here. Okay, 500 because I wanted to kind of do some bootstrapping. I hope that is able to give us the bootstrap. Like I said, bootstrapping is not supposed to be magic. And sometimes you need a very good data set. I mean, enough data set for it to be much, much realistic. Depending on your computer speed, the bootstrap might take some time. I can decide to do the bootstrapping now, or I can do it later. But I just don't want to confuse you because I've not taught you the bootstrapping yet. I need to teach you fully that computer simulation exercise. Once I teach you, you do it. So for now, I'm going to make it 0. Okay, and then run the results. Okay, so I have run the results. And how do we see the results? Just go and highlight the M, the double M in command number 111, and just control enter to see the results. And there you go. Remember, FEAR gives you the results in distance functions. So obviously, progress is going to be less than 1. So you have to take the reciprocals of every score, okay, in order to appreciate that progress is greater than 1 and then regret. I told you this earlier. But look at the first thing you get down here. Down here. What is the first thing you are getting here? The first thing you are getting is the V11. That is the own period efficiency under VRS. Own period efficiency under BRS. Then cross period, then cross period. Okay. That is the V's. Then it also gives you the constant returns. So you can see the constant returns C11, okay, C11, C12, C21, C1, all of that. It gives you both constant and variable returns. These are the components. Okay. So it gives you only the components, but doesn't, and when I say components, I'm talking about the efficiency scores, whether cross period efficiency or own period efficiency, or better still, the cross period distance functions and the own period distance function. It gives it to you. So we need another command that will give us the actual MAM quiz and then the indices. Which command is that? It's command number 8, 113. Okay. Command number 113, you call it, I call it MM1, MAM quiz, list the content of the MM, and then the level of significance is 5%. Now this is only useful when you have done the bootstrapping. Okay, when you have done the bootstrapping. But if you have not done the bootstrapping, it's not necessary. But let's run on and then see the results. So once you run and see the results, the headings of the results are as follows. So I'm just showing the names of the results, the columns. You're going to get results for MAM quiz, for efficiency change, for technical change, for peer efficiency change, scale change, pure technical change, skill technological change, scale change, and several of them. It's going to give it to you. Now, what are the differences? Well, here is a fact that you should know. It is giving you the results for FAIR. Let me write it here. FAIR. Okay, the results for FAIR. Oh, I'm trying to write these things, but yes, it's not sure. Oh, too bad. All right, let's move on. Okay, so the results for FAIR, Groskopf, Norris, and Zahn. Okay. They are the first decompositions, the three-part decomposition. They included the scale efficiency change and then the peer efficiency change. That is why you have scale here, and then the peer efficiency change there. Then Ray and Desli decomposition. Okay. What they did is that they had a peer efficiency change, but instead of scale, they had a scale change, SCH. That is what is down here. So it's going to give us that result. And then Wheelock and Wilson, they had a scale. In fact, all of them had a pure efficiency, so I don't want to go there. They had a scale, and then they had a pure technological, and then they had a scale technological. Remember, this pure technological, all of them have it. All of them have it. When you go further decompositions, like FEAR and Grosscorp, they split that pure technological. That's the one they call the magnitude index, and then the input bias, and then the output bias. All right, so I'm going to just go to the command and showcase the results. Just highlight MM1 and then just run it, and you see all the results. Let's go up. Starting this time, the MAMQuest is off and the components. So you can see the MAMQuest score. You can see. For the last one, DMUE, you can see that the score is 0.4667. When you take the reciprocal, you will get the same 2.143. Okay. That's the MAMQuest. And this is the efficiency change, which is a constant returns version. This is a technical change, which is a constant returns version. Then the rest becomes the variable returns, the pure efficiency change, the scale, the pure technological change, the scale technological change. And then finally, the Ray and Desli one, which is scale change. Now, if you look at the scale change in my own, what's the name? Selena, you can see that that one is also 11111 for the scale change. And I told you, part of the reason is because I'm using input oriented. Okay. And I drew the graph as if the Y is normalized to 1. And so obviously, most of the firms are located in a constant returns to scale corner. You can't even distinguish between a variable and constant returns to scale. So that is why you get it. So you get all of these results, and then you can take them to R again by using this command. You can organize them nicely, take them to Excel. Okay. So I decided, first of all, to take the reciprocal. First, I decided to put all of them in a beautiful column like this, okay, which you can see down here. I've given the column, the command up there. It's all looking nice. All of that, I renamed them MPI, EC, TC, PEC, nicely packaged. Then I take the reciprocal. So watch this reciprocal. I take them like this. And then in this reciprocal, if I show you, you'll see that these are the scores. Now, when you look down there in the MAMQuest, you can see that now the reciprocals are showing proper progress. So you can get a reciprocal. And the scale technological change, and then the scale change, you can see the last column, they are all 1, 1, 1, 1, just as we indicate. You can now write the results into, you can write the results into, what do you call it? Into Excel, okay? And then you can now go and see the results as it is using the command number 170. So that all of these beautiful things are now in Excel. Okay, I have another command, which is 118, where I'm doing the bootstrap. Okay, I'll hold on to that. I know you may have some questions. And then if you have, you can ask those questions and then we can address them. But when I'm doing proper bootstrapping, I'll come back here and I will show you how bootstrapping is done with this. For now, if you have a question, you raise your hand and then you ask your question. Who has a question? I see somebody type a question there. Okay, fantastic. Yeah, I need to make that point clear, that it appears that the benchmarking is a bit limited in this example. But when we are estimating the biennial MAMQuest later, and then the cost MAMQuest later, you guys will notice that the benchmarking rather is good to use than the FEAR, okay? Because it allows you to break things easily down, okay? And you're able to do that easily with that than the usual one, because the usual one, you need to impound. In the usual FEAR, you need to impound the command, which are a bit restricted to be able to calculate those things. So our next lecture, I'm going to show you the biennial Malmquist index by Pastor et al. 2011. Okay. We'll use that, and then we'll develop an algorithm for that, for the bootstrapping part. And I will also show everything I will do in the biennial, I will do it in the normal Malmquist first and show you before I do the biennial Malmquist. All right. Okie dokie.